Plastic pollution remains a global threat to our lands and seas. And since World War II, we have created over 9 billion cubic tons of it. But the recycling of it remains limited. Miles O'Brien looks at new ideas and innovations that may enable better recycling in the future. It's part of our Breakthrough series.
Imagine what it would be like to live without plastic.
Do you want to help us put the coffee grounds in the compost?
Christy Twist is determined to make it a reality for her family, daughter Ava and husband Max Del Ferro.
My ultimate goal is to not have a trash can or a recycling bin. That's my goal. I'm far from it, but that's what I want.
An engineer by profession, she showed me how she has re-engineered life at their Chicago home.
I made this mask out of an old bed sheet that had a hole in it. I needed baking chocolate, so I chose chocolate wrapped in paper that I could compost as opposed to chocolate in a plastic wrapper. So we've got a ton of bread, which comes in plastic, which is unfortunate. But sometimes I'm able to find it in paper, and if I'm ever able to find it in paper, I'll always do that instead. You know, we'll make broth or save things in the freezer in glass jars.
Christy uses an expensive private recycling service because she knows municipal methods offer no assurance the plastic she uses will be recycled, especially since China stopped accepting and supposedly recycling our plastic trash a few years ago. Just sorting it all out is a big challenge. At Pelletary Waste Systems in Madison, Wisconsin, they use conveyors, gravity, air jets, magnets, eddy currents, robots, and humans to divide the contents of recycling bins. They separate, bale, and sell 95% of the plastic that comes through here. But according to the Environmental Protection Agency, less than 9% of all the plastics produced ever get recycled in the U.S. Drink bottles and milk jugs, labeled number 1 and number 2, are most likely to be recycled. But the vast majority is eventually either landfilled or burned. Why? Well, plastics are varied and complex, and most cannot simply be melted down and reused.
So here is some of the virgin plastics that you can manufacture.
George Huber is a professor of chemical engineering at the University of Wisconsin. He showed me just some of the hundreds of plastics on the market, all of them derived from crude oil or natural gas.
So right here, this is linear low-density polyethylene, LDPE. This is ultra-low-density polyethylene.
Food packages frequently contain as many as 20 different layers of chemically distinct plastic formulations to maintain freshness, rigidity, and imprint labels.
You cannot recycle this. All of this right now will go to landfill. There's no technology that's used to recycle something this complicated today.
And that's what you're working on here.
And we are developing a technology to recycle this.
He is looking for environmentally friendly solvents to chemically reduce plastics or polymers to their constituent chemicals, fossil fuel.
We can use different solvents to selectively remove each of the individual components in the plastics. With chemical recycling, you're remaking the polymer. It is identical, has all the exact properties as the virgin polymer, as the virgin plastic. There's no change at all.
He and his team are also working on a technique called pyrolysis, where plastic is cooked in a furnace.
It's kind of like a campfire when you put plastics in your campfire and your plastics heat up and you see those fumes coming from your plastic. The same thing is happening in here, just we're not adding any oxygen so you don't burn them.
In this case, they're turning polyethylene plastic back into crude oil.
So you could use in your car to make gasoline, diesel fuel, but I think the most valuable use of this oil will be to make other plastics.
This addresses one of the other problems with traditional or mechanical recycling methods. The finished products often don't measure up to the virgin material. As a result, pyrolysis and chemical recycling ideas have caught the attention of the plastics industry. The Saudi Basic Industries Corporation, or SABIC, is building a commercial plant in the Netherlands designed to chemically recycle plastic waste. Bob Mahan is the Chief Technology and Sustainability Officer.
That facility that we're constructing now is already committed in terms of volume. before we've even had it constructed. So I think it gives you a sense of what the engagement is like in the value chain today.
Did that surprise you a little bit that there was that kind of demand?
It doesn't surprise me today, but I think if you had asked me that question 5 years ago, I think we would have gotten a different answer.
Still, advanced chemical recycling is not the sole answer to the plastic waste crisis. Improving existing recycling technology is also important.
This is the Polymer Engineering Lab.
Tim Oswald is a professor of mechanical engineering at the University of Wisconsin. His lab is filled with equipment designed to process and evaluate the performance of plastic polymers. He's trying to refine the traditional approach, creating new ways to identify and isolate specific types of plastic. So, just as a blanket statement, it is possible to make recycled plastic as good as new.
Yes.
But that's a bit of a problem?
It's a bit of a problem. I mean, obviously, we have to clean them, we have to separate them, we have to make sure that you have the same type of that material. That's technology that we're working on.
But as long as people view plastics as cheap and disposable, recycling will face an uphill challenge.
I think it's going to take a major mindset shift to see fossil fuels and plastic, which comes from fossil fuels, as a limited and precious resource that we need to think so carefully about how we're using it and how we're disposing of it.
And remember Christie's husband, Max Del Ferro? He is a chemist at Argonne National Laboratory working on advanced plastic recycling techniques. His lab is developing a process called hydrogenolysis to chemically recycle plastic, including bubble wrap.
The chemical structure of this product from the bubble wrap has the same structure of the synthetic lubricants that you find on the market.
So I'm never going to look at a plastic bag the same again. Do you? Do you look at them differently now?
I see an opportunity. There is already a lot of talking, for example, to do urban mining.
Urban mining. Imagine that. An oil patch in a landfill. Now there's a solution that will play well on the home front. For the PBS NewsHour, I'm Miles O'Brien in Chicago.